Hello there everyone, welcome back to another learning video, and today we've got another physics video, a second video on the P1 topic for the AQA course and all that, and today we're going to be covering a bit of, touching on a bit of convections and conductions, going through efficiency and, you know, all those energy resources and all that, so good fun. Right, let's start off with conduction, right? Now this only occurs in solids, and what this is it's basically the movement of heat, most likely, through the solid. And what it does is, when you heat up an object, the particles inside the object start to vibrate, you know, that's how it works, and the object starts to heat up, right? Now what it does is those, you know, knock into each other and kind of get passed on through the object and end up vibrating all the other particles and causing the entire object to then start heating up. Of course, over time they'll knock into each other less and then cool down and all that, and losing energy back into the atmosphere and all that. Anyway, that's conduction, and remember, it only happens in solids since the particles are all tightly packed together, so they have that room to knock into each other because they're all so close. Now, when we talk about liquids and gases, this is when convection comes into play. Now, convection, unlike conduction, actually just moves. The particles move away from the hotter areas into the cooler areas, and then those cooler areas then become hotter. So those energetic particles, instead of moving about so much in the air as gas, for example, or in a liquid, they just move about. They go from over here, for example, to then working its way to over here, and then it kind of heats up in that way. I hope that makes sense, of course. Now, when it comes to unwanted energy transfers, this is basically referring to when you lose energy in a system for things that you don't want to lose energy for. For example, a light bulb. Let's take a light bulb. But these light bulbs in this room, for example, there's one right up there, and there's one right up there. They're two separate colours. Actually, that one's kind of like a white, and that one's orangey. Anyway, this one, for example, its main job is to create light, and it's extremely good at it. But as a byproduct, it will also produce heat. We don't want it to produce heat, but it produces heat anyway. And then that energy is then wasted off into the surrounding environment, and it's waste energy. Okay, we can actually lose energy as well when it comes to friction and stuff like that. Let's take friction, for example. When you rub two objects together, you can just do it with your hands, and it warms them up. Okay. Now, in order to reduce friction, we can use something to kind of make it go smoother, like some kind of lubricant, for example. And that is how you would reduce unwanted energy transfer. Like, for example, if you didn't want that heat to build up, then you just add some lubricant to it and the heat won't build up. Kind of like when you add oil to a mechanism so they won't stick together and then create heat or break each other. You know, you don't want that energy in the system, so you use a lubricant to make it run smoother. Or you could use insulators to reduce the rate of energy transfer by heating. So, you know, there are different ways you can do it. Different ways of reducing unwanted energy transfer, that is. Anyway, moving on to efficiency. We know what efficiency is, right? It's basically how good you can get something done, or how quickly or how effectively, okay? That is what efficiency is. Now, there are actually two equations to work out efficiency. Now, efficiency can equal useful output energy transfer over, so that's divide, total input energy transfer. And you'll get a decimal, so you have to times it by 100. Now, if you don't have the energy inputs, you can actually use power inputs to work it out. And it's a very similar equation with useful power output over total power input times 100, of course, to get the percentage, not the decimal. Now, moving on swiftly to the main topic of this video, which is energy resources, because that's the end of topic 1 for physics, that is. And this just covers basically renewable resources and non-renewable resources and this and that and this and that. So let's dive straight into it. Non-renewable resources are things like fossil fuels, for example. And there are 3 fossil fuels you need to know. Oil, coal, and the one that, for some reason, most people tend to forget is natural gas. So remember, natural gas is another fossil fuel. Now, fossil fuels are a finite resource, and finite is a good way to describe it because it means limited. So if you have finite resources, it means limited resources. So keep that word in mind when talking about non-renewable resources, call it a finite resource. Remember natural gas, because most people seem to forget about that. I don't know why, they just do. However, you do have renewable resources and stuff like that. And these are ones that we basically can use forever. Now, there is wind power, which is just, turbines rotating, generating electricity from the wind and sending that off to the nearest place. That's basically it. And there are other ways, I say other ways, there are other methods. You can use solar panels and solar cells, for example. But in the course, it's considered, solar energy is considered as a renewable resource, and generally it is considered as a renewable resource, but the sun generally isn't a renewable resource, because one day it's gonna go, supernova anyway. So technically it's not a renewable resource, but it is at the same time, because there's a massive long period of time which we can get energy from it. So I would consider it as a renewable resource, and technically you should too, but there is that limit of the sun going supernova in billions and billions of years. I'm not an expert in astronomy, so I wouldn't know the life cycle of the sun and when it will go supernova. Anyway, moving back onto the topic which I was supposed to be talking about, renewable resources. As I said, solar panels and solar cells, the big blue panels that they have in fields on the top of houses, those are solar panels, they collect energy from the sun. Another renewable resources like biofuels and stuff, they will have specific equipment needed. So as I said earlier, with the solar energy, you need solar panels. Wind energy, you need the big turbines. And with things like geothermal energy, you need a way of getting that heat from under the earth back up. Because if you dig straight down, it's just going to get hotter and hotter and hotter until you melt to death. You also have things like hydroelectricity. Now, hydroelectricity is just using falling water to generate turbines. To power turbines. And they kind of just you have a dam, you build a dam in a valley somewhere with a lot of water, the water passes through, spinning the turbines, which then generates electricity. You also have wave power, which is by putting the generators out in the ocean, kind of bobs up and down, and it just uses that to generate electricity. It's not very efficient, I would say, because waves are unreliable, and as soon as the wind dies down, it's just going to sit there and do nothing. It's a source of renewable energy, granted, but it's not a very reliable source of renewable energy. And actually, a more common use of using the water are tidal barrages, which are basically built across big rivers, and as the water goes through the river, as it travels down the river, it passes through areas in these kind of dam-like structures. They are essentially dams at this point. At this point, they are essentially dams, and as the water goes through, again, spinning turbines, kind of similar to the hydroelectricity dam in a valley I was talking about, but this is built in a river as the river water goes through, and it's more common than the big, massive dams you get. But, we need to find more renewable resources, because, as I said earlier about finite resources such as coal, oil, and natural gases, we're going to run out one day. So, yay! You also have biofuels as well. These are basically fuels made from bio things, and bio just means life, so you can have biofuels from plants and some sort of waste of some kind. However, processing biofuels and making it all that is actually kind of pricey, I would say. It's expensive to do. Now, currently, our civilization does depend on fossil fuels quite a lot with, power stations and all that, burning loads of fossil fuels and all that, we are rather dependent on. However, I'm sure one day we'll have, the whole matter, antimatter engines that literally output so much energy we can just harness that and power the entire city with like 2 of them. I hope you guys have enjoyed this video. I hope you learned something. Remember to leave a like if you have, so that other people can enjoy this and learn what you've learned. Remember everything I said in this video, and it should help you with part of the P1 topic. Goodbye everyone.